Hello everyone, welcome back to our channel. We are excited to announce a second lecture series where we'll be diving deeper into Internet of Things. Subscribe and turn on notifications so you don't miss a single series. Get ready for insightful discussions and thought-provoking insights. Share the videos with others who might benefit, and let's expand our knowledge together in our second lecture series on sensors. So, as our world becomes increasingly connected, these IoT sensors play a pivotal role in bridging the gap between the physical digital realm. Today, we'll be exploring the significance of IoT sensors, classification of sensors, how they work and their applications, and the impact they have on various industries and in our daily lives. So, let us dive in. So, at the heart of the Internet of Things, a revolution are Internet of Things sensors. These sensors are the eyes and ears of the IoT ecosystem, collecting the data about the physical world and transforming it into digital information. These IoT sensors come in various types, each specializing in detecting and measuring specific physical or environmental conditions. So, what actually are these sensors? So, in an American National Standard Institute, the definition they give is like this: a device which provides a usable output in response to a specified measurand. That is, a sensor is a device that detects and responds to some type of input from the physical environment. This specific input could be light or heat, motion or pressure, or any one of the great number of other environmental phenomena. The output is generally a signal that is converted into a human readable display at the sensor location or transmitted electronically over a network for reading or further processing. So this is actually a sensor. So the exact thing is that it converts the physical parameters to some signal suitable for processing. So they say that this sensor is a transducer. So if the sensor is a transducer, then what is called as a transducer? This transducer is also a device which converts one form of energy to another. Say for example, it converts a signal from one physical structure to another physical structure, and it converts one type of energy into another type. So it might be used as actuator in various systems. So that is the small difference between a transducer and the sensor. So this sensor, it is actually a device that converts the signals from any one energy domain to electrical domain. So for example, there are multiple sensors like infrared sensor, ultrasonic sensor, camera sensor, smoke detection sensor, temperature sensor, and there are also some real world examples like sensing include the conversion of heat into electrical signals, and in a temperature sensor or atmospheric pressure converted to electrical signals in barometer. So these are all the things that which converts a device. I mean, it converts a signals from one energy domain to electrical domain. So how exactly this IoT sensors work? So to understand how this actually works, we need to delve into their fundamental principles. So that is, sensors are designed to detect and measure the physical or environmental phenomena such as temperature, light, or motion. They convert these analog signals into digital data, like making it easier to process and transmit. So this conversion process ensures accuracy and reliability in capturing real-time information. So once the data is digitized, it can be transmitted wirelessly or through wired connections to IoT platforms for further analysis and actions. So this is how this IoT sensors actually work. So what are the major applications of IoT sensors? So IoT sensors have found their way into various industries and sectors, revolutionizing the way we interact with the world. In smart homes, sensors enable automation and energy management, optimizing our living spaces. And in industries such as manufacturing and logistics, IoT sensors drive predictive maintenance, improve operational efficiency, and enable real time asset tracking. Healthcare benefits from IoT sensors by enabling remote patient monitoring, personalized care, and early detection of health issues. And in agriculture, it utilizes sensors for precision farming, irrigation management, and monitoring crop health. And coming to environmental monitoring, this leverages IoT sensors to track air quality, pollution levels, and climate conditions. And the transportation systems employ sensors for fleet management, logistics optimization, intelligent traffic control. And the applications of IoT sensors are vast and have the potential to transform industries and improve our quality of life. So coming to the characteristics, the general features of sensors are of two. They are mainly static characteristics and dynamic characteristics. So this static characteristics is of many types, and the major and the very important static characteristic is that accuracy. And this accuracy is nothing but which have a high quality of IoT sensors, providing the accurate and precise measurements. So this will ensure the reliable data collection, calibration, and quality control process are implemented to maintain the data accuracy over time. And the next one is the range. So every sensor has a range in which they work with an acceptable error. If the input is not in range, then the output is unpredictable. And so next comes the drift. So this is an something like if the output signal slowly changes or if the output signal slowly varies from the same input over a long period, this is called as drift. So this drift will cause an error in the measured value. And the next one is the resolution. So resolution is nothing but it is a sensor which gives a smallest change it can detect in the quantity that it is measuring. The resolution of a sensor with a digital output is usually the smallest resolution, and the digital output is capable of processing. And the next one is the precision. This is a sensor which has the ability to produce same output when repeatedly measured for the same input. And the precision is determined using some statistical analysis like standard deviation and something like that. And sensitivity, this is defined as a change in output per unit change in input of the property being measured. So the sensitivity of the sensor may be constant or linear for the entire range of sensors. And if the sensor is non-linear sensor, so the sensitivity of a sensor under real conditions may differ from the value specified. So this is known as sensitivity error. If output signal differs from the correct value, then the sensor is said to have an offset error or bias. And the next one is repeatability. So repeatability is nothing but this has ability of the sensor to measure a target property in the presence of other properties. The sensor should only be repeatable or sensitive to be measured property and should be insensitive to other property likely to be encountered in its applications. And linearity, if the sensitivity of the sensor is constant for the range, then it is called as linearity of the sensor. So these are the major characteristics of static sensors. So the next comes the categories of sensors. Sensors are categorized into three main components, that is passive or active, analog and digital, scalar and vector. So let us start with the first classification, that is passive or active. So here the passive sensors are the device that detect and measure environmental conditions without requiring an external power source. So they rely on naturally occurring energy sources such as sunlight or thermal radiation for operation. So some examples of this passive sensors are passive infrared sensors, where this will detect infrared radiation emitted by the objects to sense some motion and presence. And the next one is photodetectors. Photodetectors are nothing but which measures the light intensity to determine brightness levels or detect the presence of light. And the third one is thermocouples. This will convert the temperature which changes into electrical signals for temperature measurements. And the last is passive acoustic sensors, which will capture the sound waves to analyze audio patterns or detect specific frequencies. So this is what is called as passive sensors. And what about the active sensors? Active sensors are devices that actively emit energies or signals into the environment and measure the reflected or transmitted energy to gather information about the surroundings. So actually, these active sensors, they emit energy or signals such as electromagnetic waves, sound waves, or laser beams, and analyze the reflected or transmitted signals to determine environmental conditions. So some of the active sensors are radar, which is also called as radio detection and ranging. This will emit radio waves and analyzes their reflections to detect the presence and the location of objects. And LIDAR is nothing but light detection and ranging, and this will emit laser beams and measures the time it takes for the light to reflect back. And the third one is ultrasound sensors, and this will emit high frequency sound waves, and this will measure the time it takes for the waves to return, which enables the distance and object detection. And finally, the active infrared sensors, which is called as air sensor. This will emit infrared radiation and measure the reflected signals to detect motion or presence. So the next classification is analog and digital. So these are based on the output. So analog and digital sensors are mainly based on the output that we receive from the sensors. So analog sensors are one which measures and provide continuous or analog signals in response to the changes in physical or environmental conditions that they are sensing. The analog signal represents a continuous range of values that corresponds to the sensed quality. So how this works, this converts the physical or environmental changes into analog signals or analog current or resistance based. So this analog signals or magnitude or amplitude corresponds to the measured quantity. Some of the analog signals sensors are output of voltage or resistance value, or pressure sensors which converts the pressure change into an analog signal, or a light sensors which converts analog output that represents the intensity or the brightness of the light, that comes under analog. And next is the digital sensors. These sensors which convert the physical or environmental change into discrete digital signals. Say, for example, sensors typically employs the analog to digital, that is ADC method. This converts the analog signals from the sensor into digital form. So this ADC quantifies the continuous analog signal into discrete digital values. So some of the examples are a digital thermometer. So what this happens, it outputs a digital code or a value that represents the temperature reading. Or another example that we can say is digital accelerometers, which output digital values representing the acceleration or tilt in different axes. Okay, that is what is digital sensors. And the next comes the analog or the digital sensor, vector or the scalar. So in this vector or the scalar, here the vector sensor measures and provides information about multiple physical quantities. And here the vector sensors utilize multiple sensing elements, like it capture the different aspects of a physical quantity being measured. And the vector sensors output data in vector form, and which includes both magnitude and direction information. The magnitude represents numerically, and the direction may be represented in angles. So this vector sensors are something like inertial measurement units and compasses and 3D position tracking systems. All these are called as vector sensors. And final thing is the scalar. This is a measure and provides information about a single physical quantity, typically representing its magnitude or intensity. So here the scalar sensors utilizes a single sensing element or component to measure the physical quantity of interest. And the sensing element may be temperature sensors, pressure sensors, light sensors, or some other dedicated sensors. A few of the examples of scalar sensors are which measures the temperature of the environment and provide a numerical value. Say, for example, it can be a light intensity, or pressure sensors where it measures the pressure of a fluid or gas and provide a numerical value representing the magnitude of the pressure. So this is all about sensors. Thank you.